school in order to learn every day.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. Actually, my talk till now is a little far away from the spine surgery, but because of the time schedule conflict, it has been added in this session, and I hopefully in the near future will have applications on it for the spine. It's a new suggested navigator system, and as you all know, the navigation have been introduced in early 1990s to solve the problem of deeply seated masses. For example, in the brain tumors, when you open a craniotomy and you see that the whole sulci and gyri of the brain surface are normal, and you will be have a conflict from where I should start my procedure to reach to the tumor. So for this problem, the navigators have been introduced as a technique to facilitate reaching the deeply seated masses precisely with least sacrifice of the normal tissues. And you all know we have now in the market, there is two basic navigation systems. It's either an electromagnetic one or an infrared one. And the electromagnetic almost out of use now because it needs that all your surgical instruments must be MRI compatible before you work with it. The whole system depends on what we call registration of the patient head. You should make an image of the head in 3D, and by registration we use either an infrared cameras with fiducials. These are marks that have been detected by this infrared, or by a laser pointer. When we draw this 3D head position, we take an MRI and diffuse this position, head position with the MRI picture, so that anything I will use, I know through the MRI where I am inside the brain. In the late 1990s, we brought in Iraq these navigator systems. Mainly it was of a brain lab, and later we had the Medtronic navigation system for deep brain stimulation. But in 2009, they became out of service, and we have no more navigation systems. And we still have the problem of how to reach deeply seated masses. So we start to think out of the box. Until a few years later, we were able to create our own navigation system depending only on a free downloadable software. It is called the 3D Slicer with a presenter, lecture presenter. It is called an air mouse. The procedure starts in two phases. The first one is the pre-operative. The 3D slicer will take your MRI image in coronal, axial, and sagittal. Then it will build a 3D model, 1/1, that's to say natural size image of the whole brain, and then you cut and choose the one of intersection. Then you study this 3D image and try to determine the entry point from where you will reach to the tumor. Later on, I will come to this in more details, we draw a point at the surface of the tumor and draw a line from the surface of the tumor to the entry point, and then create another point outside in the space and connect these 3 points. By connecting these 3 points, we have a trajectory, a passage towards the tumor mass. In the operation, we use this, we call it pen mouse. It has an option called air mouse. The air mouse, it is actually a gyroscope. If I have it now, and I put the background of the computer here, and I point start on the screen, the start of the computer will work. This is what we call an air mouse. This air mouse fits with this sliding trail, and we do the craniotomy. We look for the sulci and the gyri, compare it with what we see in the 3D slicer, and choose the same point here that we determined previously in the 3D slicer image. I put the mouse pointer over the entry point, and I asked my colleague or technician to move the 3D image in the computer so that the mouse will be at the same point that I point on the actual patient. Later on, the technician will say, okay, you are now on the point. I will pull the mouse a little bit above, and with its sliding scale, I move it in 3 dimensions until I reach to the same trajectory that I already drained on the image. I will have a color change, and even I can have a sound alarm that I am on the same trajectory line. Then I will fix the sliding trail with either this is an endoscope holder, or we can even use Layla self-retaining retractor, and by that I have the trajectory of how I will be reaching to the tumor, just like that. But have we started this work? It took from us about 1.5 years to make this technique. At the beginning, we have a 3D printing model. We start to print a patient a 3D model of his brain mass and try different techniques on how to reach to the mass. In this video,
this is an actual size 3D model of a real patient with
it's only 3 minutes.
brain tumor. The model have been created using the 3D slicer, and we studied this model and decided to go through one entry point.
Actually, we were lucky after this phase of research, a Canadian company came to us. This company actually it is the manufacturer of the infrared cameras for the all navigators in the world. But recently they decided why we offer these infrared cameras, why don't we build our own navigator? And their first navigator, they call it Navient. They came to the Iraqi market and they asked me for evaluation of their machine, and I made an agreement with them. I will not give you any evaluation unless I operate using your machine for 10 patients, free of charge, of course, before I give you an idea.